So I was talking with a friend of mine, and he asked, "What are you going to talk about in the conference?" And I said, "I am going to talk about the Phoenix boot process." And he said, "That's a classic." And he was right. My first talk about Ruby on Rails was in 2006, and I explained how Rails boot at the time. And that's a younger me, right? And later I have another talk about how Rails boots. This one is from 2016 in ElixirConf. The way Rails boots changed in Rails 3. Precisely, Jose had a lot of work done there. So it changed it, all right? So yeah, this is something that I encourage you to do. Just, do a walkthrough and get into it. You're going to learn a lot from that experience. It's like a journey, all right? You start opening some initial file, and from there, go on, and you will go down to how Erlang works, and it's a journey. So when you boot Phoenix or when you boot an Erlang node, you're going to have more context about what just happened, all right? And you are also exposed to idiomatic code. I recommend it. It's a very nice experience. Let me explain you which is the talk, the goal of the talk, okay? Let's say we create a new Phoenix application, we create the database, whatever, and we run, we launch the server. What happens here? That's the goal of the talk. What's happening here? All right, it's going to be, we're going to see like a conceptual understanding of what happens here. So the code is not a walkthrough. I am not going to show listing after listing, files. It's not a walkthrough. I've read most of the involved code to prepare the presentation, but the idea is to digest what I have learned and presented it in a way that as a Phoenix developer I would like to be aware of. And there's going to be some trade-offs because otherwise the talk could be like very long. For instance, we are going to see the happy path. So you can have errors in a lot of places, and there's logic. What happens if this goes wrong? We are not going to cover that, okay? So which is the happy path, okay? Also, there are millions of flags that change how things work, okay? You can say to mix to be silent, for instance, and then there's code that says if we've been told to be silent, then we have to do the, this branch of code, So we are going to simplify some of those things. All right. Okay, so let's go with Otp Applications. So when you learn Elixir or Erlang, you start learning the programming language, and then soon you realize that there's like a layer on top of that, call it Otp, okay? The normal path to Otp is through Gen server and supervisor, some modules, all right? But Otp is much more than that module collection. There's also a set of design principles that tell you how to organize like an Erlang node, how to organize, a set of components that are building your application in the traditional, bake sense of the word. So application in Erlang and Elixir is a technical word. Okay, in the rest of the, in general, in programming languages, we have the concept of an application, which is an informal concept. But in Erlang and in Elixir, whenever you read application in documentation or books, whatever, normally that's a technical word for doing, that's short for Otp application. It's a very specific meaning of the word application. To learn how these design principles are set up, there's this section of the Erlang manual, and also I find this book to be excellent. It covers a lot of ground about working with Erlang. In this case, it's not for Elixir, but you can translate easily to Elixir the majority of the things. It covers a lot of how to work with OTP with a lot of perspective and production knowledge and everything. Excellent book. All right. So what's an OTP application? The concept of OTP application is central to understand how things boot. So we are going to go a little bit into what is an OTP application to have that very, 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 very clear. All right. So if you do not know what's an OTP application, the first thing you have to know is that it is what in other programming languages we have as library. Okay, it's like the concept of library, but it has more meaning added to the concept of library. In other programming languages, the concept of library is kind of lightweight. All right. For instance, in Ruby, you have something packaged as a library, and normally the contract, the entry point for that library is require something, and that's the end of the contract. All right. And then each one of those libraries, when you require the library, they do their own thing. Okay, this is much more standardized in Erlang and Elixir. So it standardizes a certain file structure. They standardize configuration, also how they boot, how the processes are structured, and how they shut down. Okay, we are going to see this now, except maybe for shutdown because we are concentrating on starting up, all right? File structure in Erlang projects has a certain conventional directories and etc., but we are not going to see it because in Elixir we normally work with Mix. Mix has its own thing, you know it. So for development, the structure for development, let's say we are using Mix, and that's it for Elixir. The file structure that you deploy is common to Erlang and Elixir. So in Erlang and Elixir, you will have this evin directory, which has the compiled files, prep with some assets and stuff, and then consolidated is specific to Elixir. It stores consolidated protocols. So consolidate, except for consolidated, which is an Elixir thing. Evin and prep is the directories that you normally deploy. All right. Applications are described in something called the application resource file. The application resource file is a text file that contains an Erlang term. So this is Erlang notation, because that's how the file looks. It's an Erlang term, all right? So there's a tuple. The first thing is application. In case you do not know Erlang, that's an atom. Okay, in Erlang, in Elixir, atoms start with colon, or at least the conventional syntax. And in Erlang, they do not have a column. If the word starts with lowercase, that's an atom. Okay, so application, description, ID, etc. Those are atoms. All right. And the words in uppercase, they are variables, and in this case, they mean, so this key has some value, and the value is just a placeholder, all right? This is the application resource file, and describes, it has metadata about the OTP application. So you have here application, that's the first, the uppercase application. Has the name of the application, you can have a description, an ID, version. Modules is a list of the modules included in the application, which is normally filled by build tools. Max T is a threshold in milliseconds. You can say, I want this application to run at most for this number of milliseconds. Register it is for named processes. Include applications. It's a collection of applications that you need to coordinate how to start. That's the idea. It's not related to umbrellas. Applications basically means dependencies. Emp is a very important key. Emp means environment, and that's another overload word in Erlang and Elixir. So applications have the concept of environment variable, or the environment. And that's not the operating system environment or environment variable, okay? It means so the applications have their own environment, which means some key values that you can put here and in other places. And if you read environment variable, do not think about the operating system. Normally you are talking about this environment, all right? Mod is a module that is optional, and it's called the application callback module. We are going to see it now. Start phases has to do with include applications and runtime dependencies. I believe it's not used in Elixir. All right, this is the application resource file of Ecto, or a subset of it, all right? So Ecto, as any library that you ship, or conventional or idiomatic, ships as an Otp application and has a resource file. This is a subset of it. Okay, this is all of those keys are optional. All of them have default values. So this is the minimal resource file that you can have, all right? This is a valid resource file. And indeed it's very handy if you want to tinker about the behavior of how this is processed. So it's very easy to write this file by hand, and then you add, I don't know, modules, and tweak the modules if they exist, if they do not exist, how this behaves, you know, very, very easy to tinker. So this is, all of the keys have optional, so they have default values, and this is the minimal resource file that you can have. All right. Applications are managed by two modules. Well, it's application lowercase is the Erlang module for managing applications, and application with uppercase is the corresponding one in Elixir. Through the application module in Elixir delegates the majority of the work to the application module written in Erlang. That's where the things happen, actually. So it's a thin layer, adds a little some things, but the main work is done by the application module in Erlang. When Erlang boots, creates a process, call it the application controller. It's named that way, and there's a module, call it application controller, that has the implementation of the application controller. So the application module, most of the API of this module is just a wrapper to the application controller. All right. So this is like the public API, but the actual work is implemented in application controller, which is kind of a gen server. Technically, does not implement the behavior, but you read it is practically just a gen server. All right. So we have the applications resource file. They are managed by the application module, and the application module delegates most of the work to this. This is a singleton. This is just a process that is launched when Erlang boots. All right. So now we are going to define what means to load an application. There's some jargon here. All right. We have the resource file. Applications can be loaded. Applications can be started and can be stopped. All right. We are going to introduce this. What does it mean to load an application? Easy, all right? Loading an application means loading the application resource file, which is the file that we saw before, and this is done by the application controller. So if you say load, do you see the cursor? Yeah. So if you say load this application, the application controller is going to look for the application resource file in the code path. Conventionally, the application resource file is in the evin directory, but technically it can be anywhere in the code path. Indeed, if you want to tinker, as I said before, you can just throw in your current directory 2 or 3 resource files and load them and do whatever you want, because technically that's the condition that it's in the code path. Then this is important. We have you remember this key env, which is the environment. you load the environment from the resource file, but then you are able to overwrite some of these keys. And in particular, you can pass to the Erlang shell an option which is config that allows you to put, to pass a configuration file where you can overwrite the keys that are present in the resource file. And this is relevant for releases. Releases do this. We are not going to see releases, but that's important for releases in particular. And after that, you still can overwrite even this thing with passing environment variables in the sense of OTP in the command line, as when you call the Erlang shell. And this is done for include applications. So this recurses and loads everything. This is synchronous, all right? So when you want to load an application, you do the call. When the call returns, everything is loaded. You will see, I've seen this at least in a couple of books. This is a myth. Loading an application loads its modules. So remember, there's a list of modules in the resource file, okay? Well, this is not true. They are not loaded. I've read the source code is not done, and you can test it in the console. You can load XUnit. You ask if XUnit is loaded. It's not loaded, okay? So in case you see it, out there, loading an application does not load the modules. All right. So we have the resource file, we have the concept of loading an application, and now we are going to see what is starting an application, which we are getting closer and closer to the boot process. Starting an application means the following. You load the application, which is what we just saw. You load it if needed, okay? If it was loaded already, fine. Otherwise, we are going to load it. And we check the dependencies. So there's that application's key that lists the dependencies of this application. If one of them has not been started already, this returns an error, done. There's nothing, it's an error condition, right? One of the few that we are going to see in the presentation. All right, then, if you are able to load and the dependencies are all fine, they are all started, what happens next depends on whether you have a callback module or not, which is the mod key. The mod key can be missing. In that case, there's no mod module. If the mod key is present, you have a mod module. It's the application callback module, okay? And in Phoenix, you have an application callback module, but this is not required. So if there is no application callback module, we just return OK and done. All right. The application callback module implements, technically is not needed, but normally you implement the application behavior and you have 2 required callbacks and 2 other optional callbacks. The most important for what we are seeing here is the star callback, okay? So when the application, so this is a module that has a star callback, and the star callback can do whatever you want. It's going to be called, can do whatever you want, but it has to start and link a supervisor, and it has to return the PID of the supervisor to the caller. All right, that's the key contract that has to be satisfied by this callback. It can do other things, but that's required. It has to start the supervisor and return the PID of the supervisor. All right. So what happens? We said if there is no callback module, done. But if there is a callback module, we have more work to do. So now the application controller starts a process called the application master. This application master does these things. Traps, exits, becomes the group leader. The group leader is something related to I/O, but in this case, the group leader is just a way to easily identify all the processes that belong to an application, because there's API to say which is my group leader, and that group leader is going to return the application master. So it's just a technical thing. I/O is actually forwarded to whatever was the group leader before the application master was spawned. Then, once we do this, we invoke that callback that we saw before, the start callback. Then the application master stores the returned PID, which is it has to be the PID of the supervisor, and enters a main loop. Done. It's listening for exit messages and that kind of thing. So that's done. Okay, we have the application master. Everything is spawned. Okay, when you launch the observer, the application master of an application is that process there to the left. Okay, so that process is managing this application with the chat application. The chat application is the one that we are using to study this. All right, and if you click on the different applications in the sidebar, you will see that all of them have this process anonymous to the left, but they are all going to be different because the application master is different for each. It's one dedicated for each application. All right. So that's the application master. As a curiosity, this second guy here is internally called the process X, and it's an implementation detail, but it leaks into the observer. You see it, okay? So conceptually, you have the application master linked to the supervisor, the top supervisor of the application. Okay, conceptually you have that link, but due to technical reasons that are explained in comments in the source code, there has to be an indirection through this process X, but it's implementation. Okay, so this process is also synchronous. Okay, so starting when you get the prompt back, if you are in the shell, everything is done. Okay, in particular, if you start the supervisor, well, you have to, if you are using an application callback module, then that calls a storeling, that maybe calls another storeling, that has an init function to call, you know, all that tree of calls happens synchronously. All right, another myth, starting an application loads its modules is not the case, all right? You can see this also in documentation or books. It's not the case. The modules are not loaded when the application is started. Loading modules is something totally orthogonal to this. Basically, you have two ways to load modules in Erlang and in Elixir. You can run the bin in two modes, interactive or embedded mode, they are called. Okay, if you are in interactive mode, which is normally the mode you run in development, modules are loaded on demand. So there's an auto-loading mechanism that when you first want to call a function in a module and that module is not loaded, then there's code that catches that, goes, load the module, and everything is fine, loads into the beam, calls the function, and is transparent for you. In embed mode, this is disabled, and everything is loaded when the node boots in something called the boot script. It's like everything is eager load before the applications start, and you know the modules are just the binaries and in the beam. All right, so it has nothing to do with loading or starting applications. And you can also test this. You can here we are starting again XUnit, and XUnit case is loaded. Is not loaded, all right? Okay, if you want more information about this, this source code, I find it relatively easy to read, all right? This is the application, which is the interface, the application controller, which is the one that knows what to do. It has all this logic, and then the application master, which is the one that spawns the application, you know. All right. An intermission here. We have seen that there are applications that have a callback module, like Phoenix applications do, and other applications that do not have a callback module. The callback module is optional. So the Otp application has a way to package things, has this concept of loading, starting, and in the case, if you have a callback module, some things happen. If you don't have it, some other things happen. All right. But there's no official terminology for distinguishing which is which. So in some books, you will see that they call the ones with a callback module normal applications or regular applications, and the ones that do not have a callback module, library applications. But as far as I know, this is not like well established, all right? And for instance, in documentation, you normally don't see it used. But I have the personal perception that there's a missing name here. There's a missing name. You do not have words to clearly refer to applications that have a callback module and applications that do not have a callback module. And this leaks, in my experience, this leaks. For instance, this is from the Elixir official documentation. Starting an application is done via the application module callback. Not true. If it is, if it has a module callback, but if it doesn't have, then as a user, you are left wondering, well, if I know that that's not required, so what does it mean to start an application without a callback module? This is saying, does that mean that applications without a callback module are not started? You do not know, all right? The answer is that they are started, okay? So the answer is that starting an application means what we have seen it means. If it has a callback module, we do this. But if it doesn't, you still have defined what means to start an application. This is from the documentation of a well-known Erlang library. Like all OTP applications, the name of the library has a top supervisor. Again, this is an abuse of language. Not all OTP applications have a top-level supervisor. So it is like we are missing a word to be able to express ourselves with precisely, and that's very important in documentation especially, but also in everyday life, to communicate and, be precise about it. Another one, we have here in the Observer the Application tab, right? Applications tab. And we have the applications in the sidebar. But again, abuse of language, because there are a ton of applications that are missing here. So if you were thinking that those are the applications that were started with your finished applications, wrong. There's a ton of them that are not there. Why? Because that applications tab in reality is the supervisor's trees, or applications that have a callback module. We are missing a name here. That doesn't fit in a tab name, right? So just be aware of that. Oftentimes you read assertions about applications that involve these kind of things, and in reality, what the writer had in mind is applications with a supervisor. All right. So how is this related to Phoenix? By now, we have explored the concept of Otp application. It's kind of formal, all right? We have the resource file, we have the notion of loading, we have the notion of starting. But how is this related to Phoenix? I don't know. I do Phoenix new, I do Phoenix test. What is the relationship with Phoenix? So this is very key. Mix projects manage Otp applications. So you can be very productive in Elixir, I believe, using Mix, and do not fully realize that in the end everything is an Otp application behind the scenes, because Mix gives you a very convenient interface to manage your project, and many of these things are just automated for you, okay? But in order to understand how things start, we have to make this very clear. Mixed projects manage OTP applications. Either one of it's an umbrella, it can be several. All right, so in a mixed project, you have this project function, you have this application function. So let's do a link here. Application here means technically OTP application. All right? And these keys, app, version, mode, all right? These keys map to the resource file. These are the keys of the resource file, all right? Some of them are in project, some of them are in application, and some of the keys that are allowed do not end up here. But basically, the keys that you have there map to this thing, all right? The description, the version is called BSN here, okay? So there's a translation of the key, but there's a mapping, all right? And you may say, I have never written this. What's going on? Well, it's generated by Mix for you. So for a chat application, you will see a chat.app file in your even directory, all right? And an application called foo is going to have foo.app somewhere in the code path, conventionally in the even directory of that application. So it's there, all right? And it's generated by this task, mixcompile.app, that is included in the series of compilers that Mix runs. All right. So this is the also the application callback module of Phoenix application. You will recognize this, right? This is where you declare the repo, you declare the endpoint. This file is the application callback module of your OTP application. Note that at the end, you will start a supervisor, which is the contract of this callback. All right. So we have that Mix projects manage OTP applications. And Phoenix projects are mixed projects. So if we apply modus ponens to these two premises, we get that Phoenix projects manage OTP applications. All right? So that's super key to understand this presentation. A Phoenix project is managing an OTP application, and that's wonderful. I mean, Phoenix is not special in that sense. Phoenix is just, you know, a regular citizen of the Erlang ecosystem. Everything is idiomatic, everything is packaged and you know, and managed the way you are supposed to behave in an OTP context. All right. Ruby on Rails in this sense is very different because Ruby does not have OTP. Ruby does not have these conventions. If you have a library that spawns threads or whatever, you are on your own. There's no conventions, okay? The only conventions is require. So Ruby on Rails has had to invent his own boot process. And that's not a standard because there's no standardization of that in Ruby. But in Erlang, you have this defined. So awesome. Just do this, all right? Okay. Now we are going to see Mix run. So the objective is to understand what Phoenix server does, but before that we're going to see Mix run. Mix run, I believe is pronounced. Okay, run is the default Mix task by default. So this is the default task, but you can override the default in the project, okay? But normally that's run, and you are used to use this to launch this command. For instance, the Elixir shell -s mix. That's, since run is the default, what that is running normally is the run tasks. Okay, so we are running this constantly. Okay. The run task is very important because the run task is the one that properly starts your OTP application. So in Mix, we are managing OTP applications. Run is the one that starts the application, all right? So we are connecting the dots. We have the concept of starting an application. Mix manages OTP application. Mix run is the one that starts your application. It does more things, but that's the main feature of this task. All right. Well, let's analyze this since we want to understand what's happening. First, we boot Mix because Mix is an executable, and when that executable is invoked, something happens, right? Then we have, in addition to that, the run task itself. The Mix executable is just an Elixir script, all right? So the first thing that we do is to launch the beam, okay? We know that you know everything runs on the beam, so the path from Mix to the beam is exactly that. Mix is run by Elixir, and Elixir is an Erlang program, all right? So you launch the Erlang shell to run Elixir, which is going to run Mix. Okay? This is super interesting, and it's very relevant in releases. But in the case of using Mix, which is going to be the content of the presentation, there's not too much to say about it. So we are going to jump over it. Just realize that we are launching the beam at this point. All right. Then, so we have launched the beam, and then we are going to invoke Mix start. Mix start is a regular function. It's not a callback, okay? And the only thing that it does is use this API to be able to start your application, but remember, to start your application, you need to have all the dependencies started before you, okay? So this is an API that basically says, please start whatever you have to start, and start me, all right? So this is starting the Mix application itself. So Mix is an OTP application. Everything is OTP applications, all right? And the dependencies here are just kernel, standard lib, and Elixir itself. So this is unrelated to the Phoenix application. It's just the Mix application. You see the argument there, Mix. It means start Mix, which is very small. Elixir, Mix start. The next call is Mix CLI main. And now things start happening. All right. As I said, we are going to see a subset of the things that I believe were the most important things, or the things that I would like to know as a Phoenix programmer that are happening, all right? So if present, we are loading this config file, you know, in the Mix home. Normally it's not present. Then we load the Mix file itself. Then we set the Mix environment that is going to check the environment variable or whatever, in this case the operating system environment variable. We load the configuration in config/config.exs. At this point, we know which is the environment. So in the configuration, you normally have at the bottom load, in addition to this, to what is in this file, load the one that corresponds to the environment, okay? So the environment is already set. The configuration is loaded early, and this is important, and we are going to see later how it does this, plays a role, all right? So this is Mix CLI main, and the last bullet is running the task itself, all right? So Mix task run is a generic. This run is not the same run of the task. This run is a function that runs tasks. So in this case, the run is going to be the name that you pass as first argument, all right? And now what Mix run does. It adjusts the code path, you know, to have the code path according to the project. Checks the project dependencies, You know, if you have declared a dependency and you didn't run the task to fetch it or whatever, it's going to complain. All right, you can disable these, and I believe all of them have flags and everything. But just to keep it simple, that's what normally happens. Then you run the compilers. So if there's anything that has to be compiled, it's going to be compiled. Protocols are consolidated. And then starts the application and all the dependencies. So if you are running, if you are in a mixed project, you do not need to worry about starting the dependencies in order of that kind of thing. So mix takes care of it. You just launch the application. It's going to launch the dependencies as needed. Done. If we want, it's going to preload modules. That's false by default. And if no halt is passed, it's going to sleep and just be there. All right? As I said, you can disable checking the dependencies. You can disable compiling. And those are flags that you run. But by default, that happens. All right. There's this flag in the Erlang shell that allows you to see the process. Well, not the steps that I like, not the config, loading the config, that kind of thing. But with this flag, you're going to see a report showing all the applications that are being started, all the supervisors that are being started, all the workers, the child specs, everything. All right. So that's you can see there what's happening with this repo. This is another flag in Elixir. The outcome is a little bit different. And these are the applications that I started with a Phoenix application. We are not going to see them just as a reference, and if we share the slides, you will have them. All right. Cowboy is the web server. You know, Ecto Poolboy is a pool manager that Ecto uses. And well, Phoenix is broken in a number of Otp applications. Phoenix pops up, Phoenix HTML, etc. These are written in Erlang. These are written in Elixir. Elixir is in both of them because Elixir is written in both languages. Library applications. These applications do not have a supervision tree. Note, for instance, that we have here Poolboy, for instance. It doesn't have a supervision tree. Regular applications, I used the word regular here. These ones have a supervision tree. Okay, we start this. The supervisor starts, and the supervisor has to start the children. The children are the repo and the endpoint. So quickly, when you launch the server, those two are these two. Okay, these things are started from left to right. All right. So the repo is declared this way. When the using macro for Ecto repo does a number of things. Relevant for this talk, there's a child spec generated that says I am a supervisor, and this init callback. So when you start link this module, there's going to be a number of jumps, and eventually this callback is going to be called, and you have an opportunity to change a little bit the configuration in this case, and this is generated. You can the URL for the database using operating system environment variable, right? So this starts the repo. And this is the part of the tree of your chat application that represents the repo. Okay. Those processes there on the right those are the connection. That's the connection pool. Those are connections established to the database. From the repo to the repo pool, there's just one line, and you see there Elixir chat repo. You could think that this is close. This is far away in the source code. So I've counted like 15 jumps, you know, in 4 different libraries from the point that you start the repo to where the pool is in the end created and the name assign it. How is if we are so deep, how do we have the name related to the chat application? Because the name is, or whatever has to be used to build the name, is passed in this series of calls, all right? So, the diagram does not reflect, and it doesn't need to reflect the implementation in that sense. All right. Then the endpoint, I am finishing, yes, okay. So just to here that you see if code reloading declares some flags. This is at the module level, so this is happening at compile time. And this is where having the configuration loaded before we compile plays a role, because the compiler, remember, the compiler executes. All right? So the compiler is doing the same thing as the Elixir command does. The difference is that one emits bin files and the other one doesn't. Okay, but Elixir C evaluates the code. So that's why you can put a conditional in the body of the module. So since the configuration is already loaded, at compile time, and this applies to this file and applies to your own files, at compile time you can check configuration if you need to. All right? If you have the files compiled and you change the configuration, Elixir knows that it has to recompile. All right? Okay, this is the PubSol layer in the tree. But we have no connections to the, no web connections here. The application does not have it. Ranch is an application that Cowboy uses to receive connections. It's mostly empty. Cowboy itself is mostly empty. Where are the connections? Okay, to have the connections, you have to launch a server. So you have the DB connections, you have them. But there's no one listening for HTTP requests. And that's beautiful because we have seen what run does. Well, launching the server is running the run task, the one that we have seen, with the only difference that before launching the task, there's a configuration key set. That's the only difference. It's beautiful, right? So you change this configuration and this serve endpoints, and if serve endpoints is set, the run task, the scope, if we have this set, then we have to launch the server, and this is this part of the tree that you see here. I said this is there's a pool also to handle the connections that are incoming. It's called the Acceptor Pool in the jargon of Ranch, which is the library, and I set it to 10 just for the slide, but the default is 100, so you are going to see a huge column here. So, of the summaries, the most important things to know happening. A ton of other things that happen, but the most important things to highlight them. We load the mix file, set the environment, load the configuration at that point early before compiling, then start all the applications that in proportion, this should be like a huge bullet, all right? But this is fixed with font, I cannot do that. And then we create the connection pool, the PubSol layer, and launch Cowboy. This is done in this order just because in the application callback module, we have defined the children in that order. You can also insert your own things there, and if you change the order, that's going to be reflected in the way this boots, because it goes left to right. All right? Okay, that's it. Thank you.